thank you so much for meeting with me. So to get this right, and I may have went through your LinkedIn. So you first graduated from Yale, is that?
So I got my PhD from Yale.
Yeah. Very intimidating. And then you're now at the CTO for
Quantum Computing
and
in IBM Research.
Based in the New
Yorktown
York.
Heights, New York.
Yeah, yep. Awesome. I suppose going back to when you were studying, what made you decide that you wanted to do a PhD, and that was in engineering?
So it was in solid state physics.
Okay.
So this is the early. I started in 1980 getting my PhD, and I wanted to do something in microelectronics and solid state physics. And my thought was that at that time there were no cell phones. Microelectronics was a far less capable thing, that you could see that if microelectronics could continue doing what the first steps showed, that it would be transformative. And so
you chose your field.
That'll be a fun thing to do, work in. And so I worked on making very small CMOS devices for my thesis.
Yeah.
And actually, the goal of it was to show quantization effects at low temperature inside the CMOS devices.
Yeah.
To look at the transport. And then came to work at IBM and found this little group of people that had as their mission that, because the IBM PC had just come out. It was the old box on top of the desk.
Yeah, okay, wow.
And so there was a group in research that was saying, well, that's not the future. It's not that box on the desk. It's going to be a tablet. And we had these little pieces of plastic that we had taped pictures to.
Yeah.
This is what a tablet of the future is going to be like. And it was basically an iPad.
And what year was this in?
This was 1985 when I interviewed at IBM.
Yeah.
And so there was just a handful of us. And we knew that in order to make that happen, you needed the microprocessor, but you also needed a display. And there was no display at that point. And that it's going to be liquid crystal, and it's got to have transistors all over it. So we need to figure out how to make those transistors and make the displays. And we did research, and we made little tiny ones, and we then convinced the company to do a joint venture with Toshiba. We did manufacturing in Japan. Yeah. And by the early 90s, we were shipping stuff.
Wow.
And it was an amazing ride. Yeah.
And that was your first role coming into IBM?
That was my first role.
At what point did you know that research is what you really wanted to do? So was that something that you knew when you started your PhD? Was it something you were sure at when you finished your PhD? Was it something that you became sure at after you started in IBM Research? Like, at what point did you think that IBM Research was?
So I think increasingly I don't think that I tend to do pure research. I do very much applied research.
Yeah.
So there's this sort of continuum between pure research to applied research to development to product development, and I think I've worked across most of that spectrum over the years. And it's fun to be able to follow the project through the layers as it matures. Because what you think you're doing when you start the project and what you wind up doing at the end tend to be very different beasts.
Yeah.
I mean, we started out making tablets. We were sure that had to be the future. It had to be a tablet, maybe with a pen.
Yeah.
And the ThinkPad came out, this notebook computer with a keyboard. Yeah. Because whenever we would do tests with people, they would also, I can't do this without a keyboard. I'm not touching it. I need a keyboard. And so the early notebooks all had keyboards. Yeah. And once that started, it was, the OSs were written to it, the GUIs were written to it. Yeah. And it took many, many tries on Apple's part to find the right combination to make a tablet a success. So if you look in history, throughout the 90s, there were many attempts at tablets, all of them absolute disasters.
How long was that venture, I suppose? At what point did you move on from tablets?
So in the late 90s, I did a study for Lou Gerstner, and the question that was asked by the board was, what will happen over the next 10 years with flat panel displays? Because it had grown from notebooks to desktops and things over the course of the 90s, and they were wondering what came next. And we came back and said, by 2005, a 1 meter diagonal HD TV will sell for $1,000 US. Yeah. And
How did that prediction fare? Was it pretty
it was spot on.
spot on? Yeah,
it was
yeah.
spot on.
A side business and predicting the future.
All this, it was not hard to do.
Yeah,
but IBM didn't want to get into making TV sets.
Yeah.
So they said, okay, we need to figure out how we exit this business. So at that point, we sold our display business. We kept the PCs for a while yet, but it was emotionally difficult to let go of that project because you've taken it literally from birth. And now it's a huge thing.
So you were sort of you were very much involved in IBM's transition from the hardware space to sort of the software space that it is today. I mean,
yeah, I did. Well, and
you lived through that.
Yes. Oh, and multiple times.
Yeah.
So I went on to do semiconductors and the specialized way that we package the semiconductors to get very high performance.
Yep.
And then more recently moved into quantum computing.
Yeah.
So if you think about our quantum computing program, it's really enabled fundamentally by our ability to make qubits.
Yeah.
And that allowed us to make the little 5-qubit machine, and that led to the software development on top of that to have quantum experience. And now the program is as much about the software stack as it is about the hardware.
Yeah.
In many respects, the software stack is going to be the powerful part of quantum computing for IBM.
And does in the New York center, I suppose, which focus is it? Is it the hardware? Is it software? Or is
we have more people doing software now in Yorktown than we do doing hardware. And worldwide, there's the team in Melbourne working on it as well, in Zurich and Tokyo. So we've got this worldwide team working it, but a huge it makes sense. And if you think about quantum computing, to me, the likely thing to keep happening over the next 5, 10, 15 years is that we will see disruptive technological innovation occur. If we can correctly build a software stack in the field, we can begin to pull the technological innovations into our stack and allow people to use everything they've done before and incorporate the new capabilities as they come along. And that's something that the world wants. And they're looking to somebody like IBM to provide it to them.
Provide that. How far do you think quantum is away from being able to disrupt the market or the world?
So if you think about noisy intermediate scale quantum computing, the era we're in right now, as Dario said in his talk, by the time you get to around 100 qubits, you're able to make a machine that, for the length of time that the fabric is coherent, will be able to do computations that are effectively impossible by any other means.
Yeah.
And so you have to estimate, well, how long will it take us to get to that kind of capability? And that's, we'll get there over the next 5-ish years, I would guess. But
and then the second piece is how do you commercialize?
Then where's the first spot it's going to affect, and and that's why we've got the Q network to sort of reach out and
you can gauge
let
customers
the community talk to us, and because if we have to make 100% correct guesses in order to make this a success, the chance of success is really low. If we have lots of people telling us and then participating with us to do it, our chance of success goes up dramatically.
Yeah. Is there a particular use case that you think is probably the first to be used for quantum?
Well, the most natural one is to do quantum simulation of quantum systems.
Yeah.
So you use a quantum computer to emulate a quantum system, and it's instructive to us to do that because, in general, we know a lot of the answers, so we can do problems that we know the answers to.
Yes.
And we can sort of manipulate the system in ways that the system can prove to us is doing the correct work.
You know how to validate. You can validate it.
I can do validation and verification of correct results on it. When I get into machine learning or AI or optimization, I think we're going to face a more difficult challenge of trying to supplant the existing techniques that people do. There isn't a one-to-one mapping of the solution space onto quantum in a natural way. So I think having started in someplace else where you can show that you've gotten something good, and that's going to be difficult. And building machines that will get to that level of performance is literally one of the hardest things humans have ever done.
Wow.
And
it's exciting.
And to think, we've got as good a chance as, in fact, a better chance than anybody else on the planet
to do it. Yeah, it's amazing.
What better reason to go to work?
Yeah, that leads to my next question. What makes you get out of work in a way? So obviously, quantum is really exciting. There's a lot going on. Even here at Think, but other research labs. AI and all the other fields. Is there a particular field outside of quantum that fascinates you or that has made you curious lately?
So, in general, I am an amateur radio operator, and to me, there's an interesting evolution in amateur radio that's occurred in the recent, say, 10 years, which is that when you use things like digital signal processing and the internet and network connectivity, you can use radio in ways you had never anticipated before. Yeah. And this sort of stodgy old hobby, tuning up and doing Morse code with someone halfway around the world, actually becomes a way of, you can digitally communicate, you can use a lot of the information processing techniques that we've learned in the last decades in order to do things that 20, 30 years ago people would have thought impossible. And you can do it, in your own home without spending even that much money. It's
is that a side hobby of yours?
Yes.
Oh, yes. Wow.
So there's a guy, Joe Taylor, at Princeton University. He won the Nobel Prize for the pulsar. He has written sets of software that does all kinds of error correction. Yeah. So that with very, very low power, you can communicate very, very long distances.
Wow.
So
that's awesome.
I love to do that. Yeah. For me, my personal record is from my house in Ridgefield, Connecticut. I have made it as far as Germany on a half a watt of power.
Wow!
So it's just
Cool.
nothing.
Yeah.
And
that ability to communicate out with everybody in the world with essentially no overhead.
And you can kind of predict where, nowadays there are ways of digitally predicting where you can talk to at different frequencies.
Yeah.
And years ago, none of this existed. So it's amazing to me how technology continues to transform almost every aspect of what we do in ways that honestly I would never expect.
And you can never,
and which makes the ride a lot more fun.
Totally agree. Suppose thinking a bit, bit more out there. I mean, I suppose they're predicting, over the next 50 plus years, we're going to see revolutions not just in AI, in virtual reality. They're predicting we'll be able to book a holiday to Mars. Our grandchildren are going to say to us, you just hope you had a good baby. You didn't genetically modify and produce the most optimal baby. There's so much that is being predicted that we're going to see on our horizon now, and this sort of process really started, over less than 200 years ago. We were still firing cannonballs, and to where we've gotten today, and we're sort of on that elbow of an exponential curve in technology. Is there something that particularly excites you that might be a bit far off for now, but that really excites you for what we might see as a human civilization?
I honestly believe that quantum computation probably is the most transformative technology that we are likely to see for some time to come. That it will transform society, I think, the way digital computers did in the 50s and 60s and 70s.
It'll be the same level of transformation.
Field after field will be transformed. It's difficult to anticipate how that transformation will occur.
Yeah.
It's not a linear process at all.
Yeah.
But when you can create new materials in different ways, the way in which our clothes, our food, everything about our lives
will change.
Yeah. And finding the way to do that in the best possible way for everyone is, I think, the big challenge we have.
That's awesome that what you're most excited about is what you're working on. I think that's like a privilege that not everyone gets to work on, so that's awesome. Couple more questions. I was just going to ask, if when the day comes, I suppose, and I'm already anticipating what your answer might be, when your career's over and you're looking back on your career, what would be the one thing that you'd want to say that you did, that you were able to do?
So it was a day in 1993, a Saturday morning.
Yeah.
And I was on my way back to Japan, working with Toshiba on flat panel displays. And the previous day, we had announced the first IBM product.
Yeah.
And in the United Airlines lounge in JFK, there was another customer that had a brand new ThinkPad 700C.
Yeah.
And the entire room was gathered around this guy, staring at his notebook computer and just oohing and ahhing. And I wanted time to freeze because it was the first time that you could see that what I have done and can literally change the lives of lots of other people,
amaze people,
and it's
that power
that's something everybody should strive to have that happen in their lives.
If you could talk to a younger version of yourself, would there be anything that you would tell yourself, when you sort of started out in your career? If you could go back now, with the perspective you have now, the experiences you have now, something you wish you'd known when you had started.
Don't be afraid.
Mm-hmm.
Make bold moves.
Mm-hmm.
You will fail. There are really terrible days. And but don't be afraid to make the bold moves.
Yeah.
If you think it's the right thing to do, do it.
Do it.
That it is much better to face failure and recovery than to face the thought that, gee, I really should have.
Yeah. If you could recommend one book to somebody, what would it be?
Oh, I actually just finished a very interesting book. It's called The Perfectionists.
The Perfectionists, okay.
It's about the development of precision technology.
Yeah.
It shows the impact of how, over the last 150 years, the development of precision technology, starting from England, really gives you these waves of transformative impact on society.
Awesome. Thank you so much.
Thank you.
It's been a pleasure. It's really awesome to meet you and hear your story. Thank you. Awesome.